The second exercise, draw and add diagonal lines representing A intersects B, A union B, and A minus B in the following cases. We had 4 cases, and in every case, we had to determine 3 requires. Firstly, we find the intersections for false case to indicate the intersections of set A and set B. We find the common area up to sets. I can see their intersection sets in the first figure. This is their common area. I mark with either maybe green, okay, diagonal line, green diagonal line. But there are no common area between set A and set B in the second figure, so their intersects E and empty sets C, E, and empty sets. The third figure, we realize that all element of set B is also elements of set A, so B is a subset of A. From that, we infer A intersects B, E sets B itself. 4 figure, similar third figure, but the difference from that, in this case, A is a subset of B. It entails A intersects B, E sets A. You see, this is their intersections, and in the 4 case, it is their intersection sets. This is set B itself, and this is set A itself. The next, finding out the unions up to sets is easier. We just need to take all area up to sets. So if I call D E their different sets in the figure A, this is their set unions. You see, all area. In the figure second, the same, all area, green area, diagonal lines. The third case and the fourth case. But we notice that in problem C, we call B is a subset of A, and I says so the set union between them E sets A is and set B is the answers of 4K. However, to determine the different sets up to sets is more complicated. You have to determine which element is in this set but not in other sets. In problem A, the different sets of set A and set B is the area that belong to A but not belong to B. And if I call E that set, I mark it with the green diagonal. In problem B, A minus B, E sets A itself. Because they have no common area, so all things which belong to A do not belong to B. Problem C, this A area that we need to determine, and this is a special case that we mentioned in theory session, because B is a subset of A, so the difference sets between A and P equal the complement sets of set A in set B, and we denote it A minus B E these symbols. Problem D is the special case because A is a subset of B, so all elements of A are also elements of B, so A minus B is an empty set. Next, the third problem is a real situation. I'm sure you often miss it in your class, so you try solving it. I only help you to read it. Among 45 students in class 10A, there are 15 students with excellent academic results and 20 with good behaviors, among whom there are 10 with both excellent academic results and good behaviors. A. How many students will be rewarded providing the criteria for an award is that they have to have either excellent academic results or good behaviors. B. How many students are not ranked as having excellent academic results and good behaviors? Problem 4. I am going to solve this problem fast and don't give any explanation. You should try giving them. Firstly, A intersects A equal A. A union A equal A. A intersects an empty set equal an empty set. A union an empty set E A. The complement of A in A is an empty set, and the last, the complement of an empty set in A is A. We have just finished the last exercise of the third lesson. I'm sure you can understand more if you watch more times. If you still don't get it, let me know. Goodbye for now.